Hey guys, so today in class we played around a little bit with graphing tangent, and I just wanted to give you guys some notes on that. So to begin with, let's start filling out an XY table. Now if you'll notice, this is just a little bit different of a table than we filled out in class. And for the sake of time right now, instead of using a unit circle, I'm actually just going to throw it into a calculator. So I'm going to do the tangent of 0, which by the way my mode needs to be in radians. If it's not in radians, go ahead and switch it. So tangent of 0 is 0. And then the tangent of pi over 6 is about 0.577. The tangent of pi over 4, I'm going to hit the second button and then the enter button. So if I hit second and then enter, it'll pull up that same line. And then I can just use my cursor to go back and make this a 4, kind of a handy trick. I'll zoom out so you can see a little bit better. So if I hit second and enter, that takes my second entry. Oops, I need to enter again. Second enter, and I can go back and change that to a 4. Okay, so that gives me a 1. And then if I do second enter and I hit pi over 3, I get 1.73. And now notice I'm going to be doing some values that are between pi over 3 and pi over 2. Pi divided by 3 is about 1.04, and pi divided by 2 is 1.57079. And you see in my table how these values are between those. It's between 1.04 and 1.57079. Okay, so I'm going to do tangent of 1.4, and I get 5.79. We'll round that up to an 8. 5.798, and then we'll do tangent of 1.5, and we get 14.101. And as you're noticing, these tangent values keep getting bigger and bigger and bigger. It's not like sine or cosine where the biggest we get is 1 and the smallest we get is -1. So 1.55, we get all the way up to 48.078. And tangent of 1.57 is 255 point, let's see, 766. And the tangent of 1.5, so we're getting really close to pi over 2 right now when I put in that 07 on the end. Man, and that gets me all the way up to 10,381.327. And then finally, if I do the tangent of pi over 2, I get an error. Now let's think about why I get an error message there. Well, at pi over 2, we're at the top of our unit circle. I've gone over 0 and up 1. And I know tangent is sine over cosine. So in this case, it's going to be 1 over 0 at pi over 2. And I know that you can't divide by 0, so the calculator is giving me an error message. Really, what I should be writing is that this is an undefined tangent. Okay. So if I go over then and I start graphing these points, here's my pi over 2, my pi over 4, pi over 6 is in here somewhere, so is pi over 3. They kind of hug the pi over 4, right? So 0, I'm just going to graph some of the big ones. Pi over 6 is up a little more than a half. And then pi over 4 is at 1. And we get bigger and bigger and bigger here. Notice I can't even graph really anything else on here except for my pi over 3, which is at almost 2, 1.7. And then this guy is already off my graph. If I'm at 1.4, I'm already somewhere off the graph. And at pi over 2, I get an asymptote. So this is just a teeny little baby chunk of the tangent curve, but already we can see that as x approaches pi over 2 from the left-hand side, so I'm going to use a little negative there to represent from the left, our tangent curve, tangent of x, is approaching positive infinity. Okay. And now, to save us a little bit of time, I'm going to go ahead and plug in tangent of x into my graphing calculator. I'm going to adjust my window to make it go from negative, let's go 2 pi to 2 pi. And let's count by pi over 2's for my tick marks. And then my y-mins, I'll leave it negative 10 to 10, that's fine. So if I hit graph, notice that I'm getting this wave that's occurring. And between each two waves is a vertical asymptote. So for instance, right here at pi over 2 is a vertical asymptote that you're seeing on our graph right here. So I'm going to go ahead and put another vertical asymptote at negative pi over 2. And then I can use symmetry to graph that curve down. Okay. So here's, whoa, that didn't turn out as nice as I hoped it would, but one cycle of a tangent curve. And as you can see, there's actually an infinite number of cycles of a tangent curve. If I made my window go negative 4 pi to 4 pi, I would get more cycles showing up because we can keep going around the unit circle, so we're going to repeat these values. We're going to keep having this wave repeat over and over again. So some things about tangent that you need to know. It's centered at 0, 0, so this is sort of a key point right here at 0, 0. Another key point that we graph is where it hits 1, and then obviously where it hits negative 1, which I should have graphed right there. I really wish I would have done this not in permanent marker. My graph should look like that. There you go. So it's that key point at negative 1 and at negative pi over 4. And then it has these asymptotes at negative pi over 2 and at pi. Now, the key points you're going to be graphing today, because you're going to use this as your parent function. Another important feature is that the distance it takes to do one cycle, one period of tangent, goes from negative pi over 2 to 0, and then 0 to pi over 2. So the period of a tangent curve is generally pi if nothing's happened to it. And if there's a scalar, like we're going to see in the very next problem, it's pi over b. So this is the same b value that we were talking about with sine and cosine. And it's this scalar that we're going to be looking at next. Okay. So coming on to this next problem, if I were to graph y equals tangent of 5x, the first thing I would do is say that the period is pi over 5. Now if the period is pi over 5, then my asymptotes are at pi over 10 and negative pi over 10. Because the difference between these two, the distance between negative pi over 10 and positive, is going to be pi over 5. So basically we're splitting our period up, half of it on the positive side, half of it on the negative side. Now there hasn't been any other shifts or transformations to this graph, and so when I graph it, what I would do is I would count out a couple of tick marks and put my vertical asymptotes. And I would label these guys as pi over 10 and negative pi over 10. I would then label these tick marks. These are halfway, so it's going to be pi over 20 and negative pi over 20. And there hasn't been any vertical shift on this graph or any scaling happening, and so my key points are still 0, and then at 1 and at negative 1. And then I draw my curve in nice and smooth, so it's approaching its asymptotes. So this would be one cycle of this tangent graph where the period, you know, if it's going 5 times around the circle faster, then in 1/5 of the amount of time we're getting one cycle. So it's shortening up that cycle. Now if you see something like a 4, this is going to affect the height of the key points. It's a vertical stretch. So instead of being at 1 and negative 1, it'll be at 4 and negative 4. And here, this is going to move the whole graph up 3. But on this graph, the period is not changed. It's just pi over 1. And so for us, its period is pi. And the asymptotes have not changed either, so they're at plus or minus pi over 2. It's always half of whatever the period is. So if I'm going to graph b, because it looks so much like a puppy, I would put down my graph, go add a couple of tick marks. I know I'm doing these the same distance each time, so it's really important that you label them, because obviously these 2 tick marks being pi over 2 are not the same as these 2 tick marks being pi over 10. So you make sure you put your labels on. So negative pi over 2 there, and then label pi over 4. And negative pi over 4 for our key points. Okay. When you're just getting the hang of it, it might be easier to graph the vertical stretch first as a dashed line and then move everything up as 3. So if I were to do that, I would start with 0, 1, and -1, and I could draw this as a dashed line. There would be before I stretched it by 4. And then if I were to stretch it by 4, then this guy would stay at 0. This guy would go 1, 2, 3, 4, because 1 times 4 is 4. And this guy would stretch down to -4. 1, 2, 3, 4. So here's my graph with the vertical stretch. It just got longer and skinnier, kind of. And then to graph the end result, all my points have to go up 3. So this vertical stretch goes up 1, 2, 3. I get a point there. 0, 0 goes up 1, 2, 3. I get a point there. And this guy goes up 1, 2, 3. I get a point there. So then my final tangent graph is long and skinny because of that vertical stretch. And the center point, the one that's on your axis, is moved up 3. All right, last but not least, because I know these notes are probably getting a little bit long for some of you, I wanted to show you guys something with a reflection and also with a horizontal shift. So the 3 is going to be a vertical shift, or a vertical stretch, sorry. The negative is going to be a reflection. And we're going to go pi over 4 to the right. And it's going right because when you're in the parentheses, it does the opposite of what you think. So you would normally think a negative sign would go in the negative direction, which would be left. But since it's opposite day inside the parentheses, we're actually going to go right. Just like everything we've ever shifted in our lives. Okay. So this puppy. I would advocate for doing some work off to the side of your paper before you graph too much. I'd also advocate when you can to graph things sort of together. Like if you could handle the vertical stretch, you know, as happening initially without having to graph your 1 and -1, I would do that. I'll show you what I mean in a second. So let's see. The period didn't change. The period is still pi, and that means my asymptotes, if they're half of that, are at pi over 2 and -pi over 2 still. Although those are going to get shifted right with the whole graph. So let's see, my asymptotes would have been at pi over 2 and at -pi over 2. However, everything, including the asymptotes, is getting shifted to the right. So what I'm going to do is figure that out. Pi over 4. So this guy is getting shifted. Here's my pi over 4. This guy's getting shifted right pi over 4, and this guy's getting shifted right pi over 4. So now I'm going to be at 3 pi over 4 for my asymptote, and I'm going to be at -pi over 4 for my other asymptote. I'm going to go ahead and put those asymptotes in before anything else gets too messy. Okay. Then I would have had a point at 0, 0. However, since everything is getting shifted pi over 4 to the right, that point that used to be at 0, 0 is now going to be at pi over 4 because it got moved to the right pi over 4. I would have had a point, this is me talking about the vertical stretch and the reflection, if you can deal with that all at once. My vertical stretch would have put me up at 1, 2, 3, and then the reflection would have reflected me down to -3, 1, 2, 3. So I would have been here. But that puppy gets shifted over pi over 4, so now it's sitting at pi over 2. And then I would have had a point at -3, 1, 2, 3, right here. But then the reflection, because of that negative sign, moves me up to +3, right? So I would have had a point here. But it's getting shifted over pi over 4, so now it's right here. So I've got a stretched tangent curve. It's reflected, so now its slope is going in the opposite direction, and it's been shifted over. Now, whenever you get one that has this many things going on, if you feel uncomfortable with it and you're like, oh man, I don't know if I graphed that right, you can always just pick a couple of your points and check it. Your key points and your asymptotes would be good ones to check. So if I was going to check my asymptote, like let's say 3 pi over 4, I would do -3 tangent of 3 pi over 4 minus pi over 4. I'm just plugging it into the original equation, and if it really is an asymptote, if I did that correctly, then it should come out to an error. Well, 3 pi over 4 minus pi over 4 is 2 pi over 4. And 2 pi over 4 is the same thing as pi over 2. And if I take out my calculator to double check real fast, if I do -3 tangent of pi divided by 2, notice I get an error. So that checks. This is an error, which means it's an asymptote, which is what it should be. Let's double check one more just for safety's sake. So -3 tangent, let's see, I'm going to check this point right here. That's the point over pi over 2 and down 3. And I want to see if that comes out. My x-coordinate is pi over 2, so that's what I'll plug in. So let's see, tangent of pi over 2 minus pi over 4. And now I could do this math like, you know, on the paper, which would be cool. But at this point, you can also just plug the whole thing in your calculator. And what you should get out is -3. So if I do -3 tangent, let's see, what was it? Pi over 2 minus pi over 4. And I hit enter. It gives me -3, which is exactly the y-coordinate I want. And so this checks also. A really good idea on tests and quizzes to check your graphs that way. When you think you've got the final graph and you think you shifted everything correctly, go ahead and plug it in your calculator and double check that a couple of your points really are working out the way that you think they should. All right, that's it for notes tonight. Thanks.